Hello everyone. Today we'll see the stress concentration topic. So here we will try to understand that how this stress concentration happen and what is the importance of this. So basically stress concentration is a phenomenon where the large amount of stress is concentrated at a particular point, and that happens in the areas of notches. Suppose you have a material that has notches, or it may have holes, then it may have fillets, like that. Okay, suppose you have a tensile specimen and now you put a notch over there. Okay, so this creates a area where there will be stress concentration. And normal building materials, okay, like suppose this is kind of a structure, some steel which is used, then it has got some fillet, okay, some radius. So here also there will be some stress concentration, okay, and this stress concentration will be slightly lower than these sharp edges, okay. So that also will understand like why this sharp edges design is not done nowadays, because that actually increases the more amount of stress in that area and that may lead to failure. So here you have been given example. So this is a plate kind of thing, okay. So this is a plate, thin sheet, this is two-dimensional object, and we have got a hole, okay, of this radius a, and we are applying stress in this direction, okay. This is a infinite plate, it is assumed. So when we are applying the force or the stress in one direction, in this direction, so what happens? So at the edge of this hole, the stress basically increases, and that increase is the maximum increase, and after that the stress decreases slightly and it becomes equal to the normal stress, which is what we are applying, okay. So this is what it happens in the case of circular hole. A similar thing it happens in the case of elliptical hole also, okay. Now you can see that there uh, it has drawn one generalized equation where it tells you about the forces or the stress which will be existing at the particular location around the circle. So suppose this is the circle, so at this point what will be the stress, and the at next point what will be the stress, and kind of that. So that is given by this equation, that is sigma theta and sigma r, okay. If you see the formula, then that is given in the data book. So sigma theta, or let us write sigma r first. So sigma by 2 1 minus a square by r square plus sigma by 2 1 plus 3 a to the power 4 r to the power 4 minus 4 a square r square cos 2 theta. Then sigma theta is equal to sigma by 2 1 plus a square by r square minus sigma by 2 1 plus 3 a to the power 4 r to the power 4, then cos 2 theta, okay. These are the two stresses, and apart from this there is also the shear stress which acts. So that we will not see here, we will just try to understand these things. So here you see that when we assume that, suppose this is a circle, right, and this is a circle, so now we need to find the stress at this point, okay, this point A. So at point A the value of theta will be equal to 90 degree, right? That is equal to pi by 2, right? Then what is the length? This is written in terms of r, right? So here the value of r will be equal to a. Fine. So r will be equal to a. So now suppose we find this sigma r, then we put value of r is equal to 1, right? So it becomes sigma by 2 1 minus 1 plus sigma by 2 1 plus 3 minus 4. So this becomes nothing but equal to 0. Okay, then sigma theta is equal to sigma by 2 1 plus 1, then minus sigma by 2 1 plus 3, then cos 2 theta means 2 into pi by 2, that means it will be cos 180 degree, and cos 180 degree is minus 1, right? So it becomes sigma plus 2 sigma, that is equal to 3 sigma, right? So here we are able to see that the sigma theta, which is the increased amount of stress over there, because this is the arm. So once it moves to this location where theta is equal to pi by 2, right? So this will be your sigma theta, and this will be your sigma r, and this sigma r is equal to 0, right? And sigma theta is equal to your 3 times sigma. So that means we can say that the stress which is increasing at that point of contact is equal to 3 times, and that is the maximum stress. Okay, now someone asks you, like suppose this is at just the junction, okay, just the point of the hole where it is touching the surface, right? Now at a distance of suppose 2r, if the question comes that at distance of r is equal to 2a, what will be the stress? So this is your a, next it will be your this a, so total it will be 2a, right? Then we need to check here. So once we put r equal to 2a, so in this equation, then we can find sigma r will be, again we can find the sigma r also, okay, over there, and sigma theta also. So sigma theta, if you calculate, then it will be sigma by 2, so r is equal to 2a, right? So 1 plus 1 by 4, okay, minus sigma by 2 1 plus 3 1 by 2 to the power 4, that is 16, right? And it will be minus 1, so we can write plus, so it will be 4 plus 5, so 5 sigma by 8 plus 19 sigma by 32, okay, something like this, right? So this will give us the various amount of stress, means the stress value whatever it will be at the different locations. Okay, if you go beyond very higher value of r, then there the sigma becomes equal to the normal stress, which is the applied one. So that is what it is also explained in this diagram. So here this is the normal stress, here it represented as sigma infinity, right? So this is the 3 sigma, which is the highest stress, and then it is decreasing here, right? You can see, and this is at particularly this hole. Now if you go beyond, right, as here it is shown, if you go beyond, so this is 1 radius away again, so this is your r, right, that is equal to a, so this is again it will be a, and this will be a, like that. Okay, so we can calculate, and this is the formula which I told you. So here also in this sketch it is shown. Only thing is that here the theta it has taken over here, right? Rest everything is same. Okay, so this is about a circular hole. Now what about this elliptical? For this elliptical case, basically for the case of elliptical, there will be again a stress concentration like this, and the generalized formula for this we can write here that sigma max is equal to sigma 1 plus 2a by b, where this will be your a, that is the major axis, and this portion will be b, the minor axis, right? Now from here also you can understand that for the case of circle where a is equal to b, right? So we can write sigma 1 plus 2 a by a, right? So it will be nothing but 3 sigma. So from here also we can understand that the stress concentration reaches up to 3 times in the case of hole, and in the case of elliptical crack or elliptical hole, so it will go by this formula. Okay, so according to different a and b, so the stress concentration will be it can be high, right? So here what we can say that the limit for stress concentration in the case of hole is 3 sigma. That means whenever we have a hole, then the maximum stress it can reach is the 3 sigma. This will be the maximum. But in the case of ellipse, this can go way beyond this 3, right? So depending on this value of a and b, right? Suppose I increase the value of a, right? So suppose I increase the value of a, that means the crack becomes more sharper, right? Something like this. So a value, suppose I increase it, then I can make it 10 times of b, right? So 2 into 10 times of b divided by b. So it will be nothing but 21 times of sigma it can reach, like that. So that's why whenever there is a crack, okay, so whenever there is a crack, so there is a chance that the stress concentration will occur over there and the crack can propagate. Okay, this is one thing, but this will be again explained in the fracture mechanics, that even though there are cracks, but the crack size is the limitation, like it has to have certain amount of size for the crack propagation, because it is related with the surface energy of formation of the crack also, right? Surface energy, and there is some activation energy which is needed. So that we will discuss in certain other chapter. So here we have just talked about the stress concentration formulas and how it is used. So in the basically examination, that these questions may come. Okay, now now guys, we have seen the stress at this point. Now suppose someone asks you what is the stress at point B, right? So for point B, your theta will be equal to 0, right? Fine. So your theta will be equal to 0. So now I will just take another slide and I will try to explain. So this is the point, right? So here when we try to find the stress at this point, so this line will go something like this, and here it will be sigma r, and this will be your sigma theta, right? So now we'll find this sigma r and sigma theta for here, for r is equal to a, right? So we know that sigma r will be equal to 0 because the term it is getting cancelled, right? For sigma theta, it is fine. So sigma theta will be equal to sigma by 2, then 1 plus 1, minus sigma by 2, 1 plus 3, then cos 0. Cos 0 is nothing but 1, right? So it becomes equal to sigma minus 2 sigma. So this becomes minus sigma, right? So once it is minus sigma, that means we can say that the stress at point B is equal to minus sigma. That means some amount of compressive stress is over there. Here at point A there will be tensile stress, and at point B there will be compressive stress. And this compressive stress will be equal to the nominal stress which it is being applied, right? So we have understood that here it is the tensile and here it is the compressive, and in between there will be some value, and here also it will be somewhat compressive in these zones. Okay, in these zones there will be tensile like that. Okay, so this is from one point of view, like if you try to understand like this, then during the uniaxial, okay, so during the uniaxial we have understood that here it is 3 sigma stress, right? This is 3 sigma, then we can say here minus sigma, right? Similarly at this point here it will be minus sigma, right? Now this is in one direction. Now suppose in the next case if someone applies the stress in this direction, right? So what will be the sketch? So here it will be like minus sigma, then here it will be minus sigma, then here it will be 3 sigma, here it will be 3 sigma, 3 sigma, like this, right? So this is unidirectional at suppose this is y axis and this is x axis. Now so for the case where there will be biaxial stress, so these two figures will be added. So basically here it will be like something like this, right? In all cases here it will be 2 sigma, right? So the maximum stress which will be possible in the case of biaxial stress will be equal to 2 sigma. That means 2 times of the nominal stress. So that's what the question which I have also put in the discussion forum, and this is the solution for that, that if there is a biaxial stress which is being applied, then the maximum stress concentration it can reach is 2 times. Okay, so this is it from my side. So hopefully it will help you to understand better. So thank you all.